I will discuss the variation of acceleration due to gravity due to rotation of Earth. So consider that Earth is rotating about an axis passing through its pole with an angular velocity taken as omega. So if you are just considering a particle on the Earth's surface, let's say a particle of mass m over here, then we can say that each and every particle over here are in circular motion because Earth is rotating about its axis. So each and every particle are in circular motion of different radius. So let's say over here this particle is going to move in a circle of radius take it as r. So we can write the forces acting on this object. One is the gravitational force which is exerted by Earth, that will be always towards the center, that we can take it as m into g naught, which is acceleration due to gravity on the surface. And other than that, due to the rotation of Earth, we can say that there will be a centrifugal force that we can take it as m r omega square is acting away from the center of its circular path. So we can calculate what about the value of net acceleration or net force which is acting towards the center. So if you are resolving this mr omega square into its components, let's say this angle which is known as nothing but latitude, let's say which is theta. So we can write the component as nothing but mr omega square cos theta. So we can write the net force acting towards the center. The net force acting towards the center is mg naught minus the component of centrifugal force, that is mr omega square cos theta. Now from this triangle we can write the value of r in terms of capital letter R. So this is taken as small letter r, and this is the radius of Earth, and this angle is the latitude or theta. So we can write this r cos theta is the value of small letter r. So if you are putting this value, so we can write the value of net force is mg naught minus mr. Instead of this r, we can write it as r cos theta into omega square into cos theta. So if you like to find out the value of acceleration at an angle theta or at a latitude theta, that is force divided by mass, we will get as it is acceleration due to gravity on the surface without considering the rotation into the component because of rotation, that is r omega square cos square theta. So we can say that due to rotation of Earth, its value acceleration due to gravity will decrease by a factor r omega square cos square theta. And remember that here theta represents the latitude of that place where we are finding out the value of acceleration due to gravity. As we know that this latitude is measured from equatorial line, so at pole we can write the value of latitude is 90 degree. So the value of cos 90 is equal to 0. So the value of acceleration due to gravity at pole becomes equal to nothing but g naught, which will give the maximum value of acceleration due to gravity. And at equator the value of theta is 0, so cos 0 is going to be 1. So acceleration due to gravity at equator is having its minimum value, that is g naught into r omega square, which is the minimum value of acceleration due to, and the value of this r omega square is around 0.034 meter per second on the surface for Earth. So there will be a variation of 0.034 meter per second square on acceleration due to gravity due to the rotation of Earth. So from the above information we can say that the value of g at pole does not depends on the speed of rotation of Earth, but at the equator g decreases with increase of speed of rotation of Earth. So we can say that if Earth suddenly stop its rotation, then acceleration due to gravity at poles remains constant, and acceleration due to gravity at equator increases by a factor omega square into